Good afternoon, guys. Can you guys hear me now?
Good
Yeah, good
afternoon,
afternoon.
sir.
Yes or no? Sorry, you guys broke up a little bit there.
Yes, we can hear you, sir.
Okay, good. All right, so another week, another circuit. This week we're gonna try to make this temperature sensor work, right? This temperature sensor. The code name is TMP36, right? And it has 3 pins, right? 2 of them, power and ground, is how we power the sensor. And this third pin, V out, sends an output signal based on the temperature around the sensor, right? So you put the sensor in the room, or you put the sensor close to a hot object, right? The voltage that comes out of here would be varied based on how hot that object is. Now, what's most important is when you go about building these circuits, it's important to know how the sensor is calibrated, right? What is it designed for? What's its operating range? Okay, because you can have a sensor that's rated to say, let's say 32 degrees Celsius to 100 degrees Celsius, right? Which is fairly hot. And then you can't go and measure how cold ice is because it's just not designed to measure temperatures accurately in that range, right? So first things first, when designing a circuit like this, you need to choose your sensor wisely. Now, sensors would usually come with a particular data sheet. All right. So you can easily find a data sheet by just Googling the temperatures, model number, or code online. 1 second, guys. Can you guys still hear me?
Sorry,
Yes, sir.
breaking
Yes.
up bad.
I'm breaking up worse now.
Do you
Well,
change
it
the
seems to
headset
be
or
fine
something?
now.
Is is it clear now?
Yeah, sorry, it seems to be clear now.
You sound
Okay.
different though.
Yeah, because I use headphones now. Before it was just the plain mic. Yeah. So as I was saying, you can just Google the model number, go to the manufacturer site like analog.com, microchip, wherever makes the sensor, and you can find a data sheet. And this data sheet is going to tell you exactly what this sensor is rated to do, right? It's going to tell you things like, you know, let's see, the supply voltage, the temperature that you should store it in, and also things like up here, tolerance, right? So this sensor was tested around 25 degrees Celsius, and you can expect like a tolerance of plus or minus 2 degrees Celsius, and all sorts of different things, and it might give you a range that the sensor was built to operate in, and things like that. And you can go through. Right. So now the sensor that I pulled out, on tinkercad.com was TMP36. Now, before we start designing a circuit for this sensor, we should first understand, hey, what voltage is going to come out to the sensor, right? Because based on what temperature it sees, it's going to output some voltage, right? So we're looking at here,
B, right? B here, right? TMP 36. So that's this line here, right? This one here. Okay. Now, what this graph tells us is that when the sensor sees 0 degrees Celsius, it's going to output about 0.5 volts, right? When it sees minus 25 degrees Celsius, it's going to output about 0.3 volts, right? This here is in voltage. This here is in degrees C, right? When it sees something like 25 degrees C, it's going to output like 0.75, right? About 0.75 volts, right? So if we go to ThinkPad, you'll see it's fairly interactive. And you can click on the sensor and you can slide the temperature back and forth. Now, in the real world, that would be the same as sticking it in hot water or putting it close to a solder iron or a bulb that gives off a lot of heat, right? You're changing the temperature and you'd see the voltage vary. Okay. Now, if you, let's say you had a sensor and you didn't know what the model was or the data sheet was, right? You can always pull up something like a multimeter, right? And you can connect one end up to ground, connect one end up to the signal, and then move it next to hot objects or maybe something that you know the temperature of, right? Like boiling water, you know, water boils at 100 degrees Celsius, so you can stick it in there, right? And then see what voltage comes out, right? And then try and figure out the characteristics of the sensor. Okay? So I'm pretty sure you guys have been doing a lot of math in school, right? Now we're gonna learn to apply that math to figure out how should we go about coding the sensor into an Arduino, right? Now, wouldn't it be cool if there was some way we could relate a function of the voltage to the temperature, right? If we look at this, this is just a straight line, right? And we know that the equation of a straight line is, let me type it instead of write it, y is equal to mx plus c, right? Good. That's something you guys know. Now, how can we convert this into this and put some actual values, right? So we know c is the y-intercept. Good. So then we need to adjust the way we're looking at this a little bit, right? We need to think of the Cartesian plane as here. And 0 is here, right? So 0 would be here. So the y-intercept would be this point, right? Let me put in a red. Would be this point here. And the y value there would be about 0.5, right? Let me erase that so you guys can see. Does that make sense that the y-intercept would be 0.5?
Yes, sir.
Okay. 5. So let's change y to not y, but v for voltage, right? Or we could say v out. Yep. Now, x is going to be temperature, right? So we can change that to C, degrees C, or we can just change that to temperature, right? Temp C. That seems like a suitable name. Now for M, okay, we need to find the gradient of this line. Okay. Now I can tell you because I looked at this problem before, and I know the gradient of this line is 1 divided by 100. Now, how I found that was I picked 2 points that I knew, right? I knew 0, right, which goes to 0.5. And I know 25, which goes to 0.75. And I formed this equation, right, which is probably one you guys are familiar with, that we use to find the gradients of lines, right? We can say m is equal to
Change in y over change in x.
Yep.
We change the voltage output.
Yep.
We change the
So-
temperature.
so the change in x, we're going to be moving from 0 to 25, right? So from 0 to 25, and then the change in y, right, is going to be from 0.5 to 0.75. Now this here is going to simplify to, right, 0.25 divided by 25, right, which is m is equal to 0.01 divided by 1, which
So 0.0.
is equal to 1 divided by 100. Right? Does everyone follow that math?
Yes, sir. Yes,
Okay, good. So we end up with an equation like this. So now, if we can read the voltage, right, coming into this circuit when we start the simulation and move this slider across, or if we're in real life, we put hot things next to it, we can read the voltage and say, when we read this volt, that's however many degrees C, right? So keep this equation in mind. Now, the output that we want is degree C. So if we were to, algebraically manipulate this equation, it would be V out minus 0.5 V out minus 0.5 times 100. Times 100. Okay. And we can take the voltage we get in, we can minus 0.5, we can multiply it by 100, and then we get a temperature in degrees C. Right? Now, that's the mathematics side of it. That's the relationship between voltage and temperature. So now let's build the circuit now that we have this equation. And I trust everyone is following along so far. Okay. So again, how we wire up the circuit, simple, right? 3 different pins on the sensor, the power pin to power, the ground pin to ground, and the signal pin, the signal input, right? How we know this pin out, again, from this data sheet, it's going to tell you which pin is which, right? Again. Now, you can forget about this top section a little bit for now. We're going to say int sensor data equal analog read sensor, right? That's going to read the signal coming from this sensor. Then we're going to do this little manipulation here, right? I'm going to come back to this, right? And this manipulation converts a semi-digital signal from the Arduino into an actual voltage. Then we're going to take that voltage and we're going to do the equation, right? Voltage minus 0.5 times 100. Okay? And then we're going to just print that serially. We're going to print temperature in Celsius, right? Colon right? So this is going to show up as like a string, and then we're going to print that variable. We're going to print character 176, which is just a way to make that degree symbol show up. And then it's going to print a new line, degree C, right? It's going to print degree C, then put the next stuff in a new line, so that when we print something, right, it types out in one line. And if we do print again, it types out in another line. When we do print with the ln, right, it types something out, prints it out, but it has a new line character at the end of that, so that the next thing that comes in a new line. Okay? And then what we're
Sorry,
gonna
you're
do,
breaking up.
yeah, it's probably just the internet. Okay? And then at this point, we're just gonna convert to Fahrenheit, and then we're gonna do the same thing, right? Print in Fahrenheit. Now, the part that I just glossed over was this part here, where we convert to a voltage, right? Now, Arduino, by default, when we collect an input voltage, right, it reads it from a value of 0 to 5 volts. And based on what value it is, it has an analog to digital converter, right? ADC, analog to digital converter. And that converts it to a digital number between the values of 0 to 1024. Okay, so let me maybe paint that a little bit. Okay. Okay. So as I was saying, now the signal here comes in from the sensor, and the signal is of a range from 0 to 5 volts, right? The Arduino on those analog input pins has an analog to digital converter, right? The analog to digital converter converts every value from 0 to 5 volts to a value from 0 to 1024, right? Now, this step here that we do here is to undo that, right? So we're taking whatever that sensor data is, right? We're making it a fraction of 1024, and then we're multiplying it by 5 volts to essentially reverse the process, right? To go back, to undo the process so we can get the volt, right? So that's what this line here does, right? Does that make sense to everyone?
Yes or yeah.
Hold on, sir. Hold on.
Okay, good.
Sir?
So the voltage comes in to the Arduino. The Arduino has a analog to digital converter, right? That helps it read the signal in a more defined way, right? and not have a lot of noise within it. So it takes that signal and converts it to a number from 0 to 1024. Now we want to know what voltage came in because we have a relationship we set up, right? We have a relationship we set up between temperature and voltage, right? Not temperature and ADC converted signal from Arduino, but temperature to voltage out coming from the sensor. So what we do is we undo that process, right? We undo that process. If you think of this, between 0 to 5, there's some value like 2.5, right? Something here like 2.5. Let's put in a different color. That 2.5 would probably map to something like 500, right? But this would be digital bit.
512.
Yeah.
Yeah.
So what the Arduino doing is just mapping all the different volts in between from 0 to 5 to values between 0 and 1024. Okay.
Sir, question, sir.
Yep. Go ahead.
Yeah. Yes, sir. So the Arduino, based on what you have said, sir, the Arduino has an ADC inside the system itself, right? So,
Yeah.
sir, for for this for the temperature shows the reading of what the temperature is, all right? So
Yeah.
it's actually based on the volts, right, sir? And then the ADC is just turn it into a number that would like suit what temperature it is, sir.
No. So the ADC converts it to a number within this range, right? And
Yeah.
now
Mm.
we need to just reconvert it to a voltage, right?
Okay.
This ADC operates based on a reference voltage, right? There's a lot more complicated things that go into this. Maybe I can explain that in a later class. But there's some reference voltage in the system. By default, that reference voltage is 5 volts, right? Now, as you get more advanced and you do more advanced projects, you can change the reference voltage. And that essentially just maps all the values from 0 to 5 volts into different digital numbers, right? That we can use to translate them back to voltage or use them exactly as they are and manipulate them in some way, right? But in order to read the voltage properly with a decent resolution, right? Because 0 to 5 volts, it's like when you think mathematically, we got a bunch of different values in between, right? The Arduino would need to be very sensitive in order to pick up all those different minute changes, right? An analog to digital converter helps to discretize that signal, right? And represent it in a manageable digital way, right? And you remember there's some pros to having digital signals, right? So when we get it as a number, this is a solid number, right? It's not fluctuating, it's not changing that much, right? This is a solid number, right? Based on a predefined resolution. So it's a number that's good enough, right? And then we can go back this way and get, okay, this signal came in, the Arduino is gonna automatically output this number, but we actually want the voltage, so we're just gonna do the reverse of the process, right? And this equation here is the reverse of the process. And if you think of it mathematically, it kind of does make sense, right? But that's what that line there does. Okay? Does that make sense?
Yes, sir.
Good. And if it doesn't, let it sit a little bit more, right? And maybe 2 weeks from now or 1 week from now, you'll be like, oh yeah, that does make sense, right? Okay, good. Now, I ignored some lines from the beginning. Did I ever use serial begin and serial print with you guys as yet?
Not yet, sir.
Okay. Okay. I might have used it one time, but now this is a more, we're actually using it in a program now, right? Okay. So let me get up a new. So we've got, here is the computer, right? Your computer. Let's just type the word Arduino. Right. Then we will type in red. Okay. Okay. So now you type up some code, you put in your computer, and your computer loads that onto the Arduino, right? Let me try giving you guys a visual of how that looks. Let's see if we get lucky and get an image for what that looks like, right? But it's simply an Arduino connected up to your computer via a USB cable, right? I mean, if you look in this image here, right, you see the cable here comes in, is plugged into the Arduino, and it would go into your computer, right? If you guys ever get a chance to go into the electrical lab, you can go to maybe the lab tech and show you some Arduino megas, and you can touch them and start plugging them up to the computer, and you can look at them, right? But this here, yeah, you just plug this in here, and this end would go to the computer, and the computer would send code into the Arduino. You can load it. Now, this here is one-way communication. Sometimes you might want the Arduino to speak back to us, right? Speak back to us. The way we get it to do that is through serial communication, right? When we want to establish communication both ways, we can do that serially. Serial communication. Now, this is done over USB, and USBs operate with some baud rate, and a baud rate specifies, how fast we would modulate the waveform, what type of waveform, frequency of modulating, space between bits, stuff like that, right? And you can look into it. You can look into serial communication, right? This 9600, right? Serial communication is the standard protocol, and 9600 is just the rate at which data is transferred, right?
Sir, can you hear me now?
Yes. Okay. So,
Sir?
Yep.
Sir? Sir,
Yep, go ahead.
it is known as the rate at which data is.
Yeah, the rate is which at which data is transferred, right? This is the baud rate.
Okay, sir.
Right? It's a number we can specify. Now, the baud rate, when we set it here, it essentially tells the computer, hey, when you're monitoring for data, look at this particular frequency, right? Because both ends of the system need to be set up with a particular baud rate, right? If here is sending information at a baud rate of 9600, then here must also be looking for information at a baud rate of 9600, right? If this here is sending data too fast, and this is looking for a slower waveform, they're not going to be able to communicate, right? Remember from digital electronics, sometimes we will need a clock to sync things up, right? And that clock allows us to, time the changes in the digital waveform and see what is a bit, what isn't a bit, right? How long does the bit last, right? To be able to understand things. So this number, this 9600, helps the two devices to communicate. Right now you can change it, but there's some limitations to how much you change it and how long the cable between your Arduino and your computer could be, and different things like that, right? But that's more for like a telecommunications class than this class, or like a network engineering class than to this class, right? But you can research as much as you want on serial communication. Right? So that's what we're doing here. We're telling the Arduino, hey, make sure we got communication channels set up, and we're going to use the 9600 baud rate because this is pretty standard for these microcontroller communications. Right? Now you can use higher, you can use lower, you can use 9800. It's perfectly fine as well. Right? But this is just, a standard number that most people usually use. Right? And then with this functionality comes things like serial print, right? Serial print ln, which prints and then puts it in a new line, right? And that's it, right? So you start the simulation, and your Arduino is going to start working and doing the code. And on your computer screen, you're going to see data coming back to you, right? Okay. You can set it up in Python to monitor this, right? Or, Windows PowerShell, or you can monitor it over your command line, right? Or you can use the Arduino built-in serial monitor, right? There's lots of different ways to monitor this, right? But essentially, you'll see text-based data coming in similar to this. Right. Let me see how to get this bigger. Yeah, you'll see text-based data coming into this, right? And remember, code is set up like to see what the temperature is in Celsius, print that out, convert it to Fahrenheit, see what the temp, and print the temperature in Fahrenheit out as well, and then delay 1 second in between. If you don't want it to update that fast, then you know what you can do, right? Change how long you delay for. Right? Good. So that's the code. Any questions, guys, on how this whole thing functions? No. Okay, good. Yep, go ahead.
Sanya.
I can hear you.
Sir, you finally hear me now, sir. I can knock out most of the class, me know what's going on, and also I don't know if you look, I don't know if you hear it or not, but you didn't respond.
Okay, probably weren't hearing you. All right.
You're gonna again just now. I have to switch to
Okay.
device.
So, well, you can learn by doing, right?
You still hearing me, sir?
Yeah, I can still hear you. You can learn by doing.
Sir, you hearing me?
Yes, I am hearing you. I'm
Sir,
saying you're gonna learn by doing. Oh, okay. So yeah. So the rest of the class gets start, right? You know the temperature sensor, right? TMP 36. And the code is right here, right? I can scroll down a little bit, but at the end here is just delay and serial print line, which you guys can figure out how to, do that. But go ahead, start the program. Any questions, please feel free to ask. And when Shiv comes back on with his mic, we can answer his questions too. All right.
sir.
Yeah, Shiv.
Okay, sir. So the last part what I left you, sir, was when you went explaining y equal mx plus c,
Oh, okay. Yeah,
and then
there's a while back.
when I
Yeah.
come back the next time, you went at some line with 5.0 divided by 1024. You said that was
Uh-huh.
some conversion,
Uh-huh.
and then after that, I get a hard time coming back on.
Okay.
So I
So
only remember you doing them two things.
the class is being recorded. I'll send you the link, right? Or I'm sure you guys can access
Making
the
you
link
properly, sir.
from the previous class.
So
Can
I'm gonna
anyone
send
else?
you a message and tell them so.
Yeah. Okay. Because you guys can hear me fine, right? Right? You guys can hear me clear. It's just Shiv having issues.
Yes.
Well, oh no, I can't scroll it. I gotta hide it because you guys should be able to figure out what that line is, right? We're converting degrees Celsius to Fahrenheit. So how do we convert degrees Celsius to Fahrenheit? You can just Google the formula, right? Celsius. Okay. Right, and then figure out that. And who knows, my code could be wrong. And you guys copying it.
Excuse me, sir.
Yep.
After compiling the code and running it,
Yeah.
I could see that it doesn't have an ending. It's infinite.
Yeah.
Is there a way to separate that or segment it into days?
What do you mean?
Like if you want it to run for 24 hours to stop, then run for another 24 hours?
Yes, you can. Would
Okay.
you like to do it now, or would you want me just? I'll tell you what. It involves this function called millis, right? Uh, I know that's how you do it because this is a function. The output of this function is how long the program has been running. So you would do something like if, you know, the output of this millis function was greater than 24 hours. Of course, the output is in milliseconds, right?
Right.
Is greater than 24 hours, then exit or break or delay, right? And they would, exit the program. Then end. Yep.
Okay, sir.
Yeah, I can look into it. Usually I don't remember every single function, right? That's why the Arduino reference is so helpful, because they're like, hundreds of functions. It's really hard to remember all of them, right? So you can always refer back to that reference and see what the functions are and how exactly the syntax is typed up. Right?
Oh, all right. Thank you, sir.
Great. But I'll probably type it after class and send it to you guys, if that would work.
One more thing, sir.
Yep, go ahead.
After getting the output, how do we export it to an Excel sheet for analysis?
Well,
Like
you
taking
can
it from the
collect it on your computer. So you can honestly use like Python. I'm not sure if I got Python on this work computer, but you can use all sorts of different programs to read over the USB port, right? You'll just be serially communicating through a USB port. You can use programs like PuTTY, Python, even like bare bones C, right? If you're on a Linux machine, is
Oh, the Linux.
particularly it's easier on that because it's more low level and you got a lot more access there. But the different ways you can use to collect that information, and you can collect it in a CSV file, and CSV files are easily converted to text based. Text based can easily be converted to the Excel sheet. So a lot of different ways, but very computer sciencey. So, but yeah, you can look into it. But it does take some troubleshooting, because I'll tell you, reading over USB from a computer and a system like Windows is not very user friendly. So it does take a little bit of troubleshooting, but it's
Most
a
of the
good
ports are
learning
closed.
process.
Windows, the ports in Windows do not allow access, so you get a lot of errors.
Yeah, so you might need to do some troubleshooting and work around here and there.
Sir.
Yeah.
Sir, the project that we did last week, sir, with the LCD display, sir.
Yeah.
Sir, my own is running, sir, but nothing in display on the screen, sir.
Okay. Could you send me a link to your code?
Sir, you want share the screen, sir? Share quick and done.
Well, other people are copying the code, so.
Alright, sir. See after the finish.
Yeah. Or do you guys want to take a quick screenshot of the screen and we could go from there? Okay. Another question, does anyone know what this line here is? Hashtag define sensor A0. Because we use the word sensor here, but we never did int sensor or char sensor, string sensor, nothing like that, float sensor, right? We never use a data type, right? We just define sensor as A0. And then we used it here. So does anyone know what this line is doing? If you don't, might be something good to research, right? And figure out what it is.
Define sensor. I think because the input on the machine is analog signal?
Oh, well, no. I mean, you can probably just type A0 here and you would be fine too, right?
Right.
So, I mean, no need to do that, right? But why do we do it? So the difference between doing something like, let's say, int LED pin is
As an
equal to
integer.
13, right? And hashtag define LED pin 13 is that this one here is a constant which cannot be changed. Like you can't change it at all. And this one's a variable which later in the program we can say if, right, blah blah blah, LED pin is equal to 12, and we can change what the LED pin is, right? If we do hashtag define, there's no way to be able to change the LED pin. The LED pin will stay that way, right? So hashtag define, it's one way which we can use to define a constant in C. There are, I think, about two other ways that you can define a constant in C, but this is a very common one. Now, it does not relate to a library. The only thing it shares with, accessing a library is that libraries also use the hashtag, but they do use hashtag include, right? And then you'd probably have something like stdio.h, right? And that would be a library file, right? Or in the case of your LCD, right? Just another thing you should know while learning to code C, C++, microcontrollers. Okay?
Yes, sir.
Yep.
Sir, can I share now, sir?
Yeah, go ahead. Did everyone screenshot the screen?
So I just scroll down to the bottom. Click again. Bottom.
Yep.
Yeah, it's okay.
Okay, I'm gonna stop sharing now so Haroon can share. Haroon, go ahead.
Sir, did you enable attendees screen sharing, sir? By telling me who's disabled attendee screen sharing.
Okay, try again.
Yeah, come on.
Okay, good. Is it the first one? Press start simulation. Ah, okay. Before that, just minimize your code real quick. Okay. Click code. No, yeah, just okay. Could you turn your potentiometer all the way to the other side? No, like the oh, you probably need to start simulation maybe to do it. But yeah, well, you can't start simulation. I think if you just click on the potentiometer, yeah, like click where you want the dial to go. Should be whatever. But I think even if you get your code to work, it's not going to show up because your potentiometer is the other way. Yeah, but let's look at the errors in your code.
Pardon, sir?
Go ahead, click start simulation and let's see the errors in your code. Okay, so the first so in line 3 where you see in seconds equals 0, you need to put a semicolon at the end there. Yep. No, semicolon, not a colon. Start simulation again. Okay, so LCD_1 print Haroon, put a semicolon as well there after Haroon.
Pardon, sir?
In line 12, the end, semicolon. Yep, start simulation. Now,
Still not.
good. Now turn the potentiometer. All right, turn it. Okay. Okay, working.
Yes, sir. Yeah.
All right, good. You can stop sharing.
All right, sir. Thanks.
Good.
So, sir, it has always got turned on the highest dose, sir.
Yeah, so the potentiometer controls the contrast. So if you turn it a little bit,
Okay, all right. Thank you, sir.
you can probably set it up in a more complicated resistor circuit to get, finer tuning, but that's too much work.
All right. Thank you, sir.
Yeah. Everyone else getting through?
Sir,
Yep. Go ahead.
just sir, his only this we are doing for today, sir.
Uh, well, I had some other stuff, but I don't know how quickly you guys will finish. I can send it for
Oh,
homework.
for homework.
Yeah, it's not
Yes,
hard.
sir.
It's
Yes,
the
sir.
same
Yeah.
concept. But I wanted you guys to use this temperature sensor instead of printing it out to here, right? Print it out to an LCD screen, right? Print it out to an LCD screen. You guys think you can maybe combine you can combine the two pieces of code, the LCD screen and this temperature reading code. You don't have to convert it to Fahrenheit. You can, remove this piece of code. You can simplify it a little bit, but can you, instead of having the serial monitor display the information, can you have an LCD screen display that information? So that's a good project. It could work.
Yes, sir. Yeah. I think we could handle it, sir. Yeah.
Okay.
So, sir.
Yep.
So, sir. So you everybody construct the temperature with the LCD for next week Monday, sir.
For homework, I mean, you're not going to be graded on it, but I will be sending out a project that'll test these skills. So would be good to know it.
All right, sir. Okay, sir. All right, sir.
Yep.
So sir, I just want to know if this is it for the class, or because I get a little spin for next year. So just asking. Anyone else left the class and you know to get more?
Yep. Yeah. Go ahead. As long as you finish the program, I'll send out an email.
Huh?
Yeah. Feel free to leave. Anyone else that's finished, feel free to leave. If you have any questions, you can stay and I'll answer them. Or if your code isn't working, you can stay back and I'll look at it for you. Is someone else trying to say something?
Sorry, Aaron.
Sorry, I wasn't hearing anything.
Sorry, so then the project that you sent us, will that be the final thing for the semester?
No, there's one more other assignment.
Okay, sir, thank you.
Yeah, because you guys had 2 assignments already, right?
Yes, sir.
Okay, good. So 2 more. Yeah. Then your final. When is final exams for you guys?
So it's
I'm sorry, you cut out. Yeah, I can't hear you.
it's finishing the 21st of July and starting, I think, is the 2nd of July.
Okay. Okay. There won't be a final exam for this class. There'll be like a final project though. So look forward to that during the exam period. All right. Any other questions, guys? Nope. Okay. If you guys don't have any other questions, I think I'll close it off here for tonight. Enjoy the rest of your night, guys. Bye. I'll send out an email with the code and the screenshots to you guys.
Recording